Our planet Earth is a place of constant change and incredible power. While we experience the gentle breeze and the warmth of the sun on our skin, deep within the Earth, forces of unimaginable scale are at work. These forces, responsible for shaping the very ground we walk on, manifest themselves in two awe-inspiring phenomena: earthquakes and volcanoes. Earthquakes, with their sudden and violent tremors, remind us of the immense energy hidden within our planet. They are capable of reshaping landscapes in the blink of an eye, leaving behind a trail of destruction and change. Volcanoes, on the other hand, offer a more dramatic spectacle. These fiery mountains, spewing molten rock and ash, are a visible reminder of the Earth's molten heart. Both earthquakes and volcanoes are born from the same source, the movement of Earth's tectonic plates. These massive slabs of rock, constantly shifting and grinding against each other, are the architects of our planet's ever-changing face. Over millions of years, their relentless dance has sculpted mountains, carved out ocean basins, and given birth to the continents we inhabit today.
Imagine the Earth's surface as a giant jigsaw puzzle, but instead of stationary pieces, we have massive plates of rock in constant motion. These are the tectonic plates, and their slow, relentless movement is the driving force behind earthquakes and volcanoes. The Earth's outer layer, the lithosphere, is broken into these plates, each one moving at a different speed and direction. Some plates pull apart, creating rifts and valleys, while others collide head-on, forcing one plate to slide beneath the other in a process called subduction. These plate boundaries are where the action happens. As the plates grind against each other, immense pressure builds up. This pressure, like a coiled spring, seeks release, and when it finally gives way, the result is an earthquake. The Earth's crust shudders and trembles, releasing energy in the form of seismic waves that ripple outward from the point of rupture.
Imagine holding a twig and bending it slowly. It bends and bends, storing energy until suddenly it snaps. That sudden release of energy is similar to what happens during an earthquake. The pressure between two tectonic plates becomes too great, and the rock breaks along a fault line. The point where the rupture occurs deep within the Earth is called the focus of the earthquake. The point directly above it on the Earth's surface is the epicenter, and this is where the most intense shaking is felt. The energy released during an earthquake travels outward in the form of seismic waves, causing the ground to shake and tremble. The intensity of an earthquake can vary greatly. Some are barely noticeable, mere tremors that we might feel as a slight vibration. Others, however, are powerful enough to topple buildings, trigger landslides, and even generate tsunamis if the earthquake occurs under the ocean floor. If you were to trace a line around the Pacific Ocean, from the tip of South America, up through North America, across to Asia, and down to New Zealand, you would be outlining a zone of intense volcanic and earthquake activity known as the Ring of Fire. This horseshoe-shaped region is home to around 75% of the world's active volcanoes and is responsible for 90% of the world's earthquakes. The Ring of Fire exists because it marks the boundaries of several major tectonic plates. Here, plates are colliding, subducting, and grinding against each other, creating the perfect conditions for both earthquakes and volcanoes to form. The Pacific Plate, one of the largest tectonic plates, is surrounded by other plates that are constantly pushing and pulling. This constant interaction is what fuels the fiery temperament of the Ring of Fire. From the towering volcanoes of the Andes to the earthquake-prone islands of Japan, the Ring of Fire is a testament to the Earth's raw power. Section 5. Mountains of Fire, the formation of volcanoes. While earthquakes are the Earth's way of releasing pent-up energy, volcanoes offer a more dramatic display of the planet's internal heat. These fiery mountains are formed when molten rock, known as magma, rises to the surface from deep within the Earth. Magma is created when rocks deep within the Earth's mantle melt due to the intense heat and pressure. This molten rock is lighter than the surrounding solid rock, and so it rises, seeking a path to the surface. When magma reaches the surface, it erupts as lava, ash, and volcanic gases. Volcanoes often form at convergent plate boundaries, where one tectonic plate is forced beneath another. As the descending plate sinks deeper into the Earth's mantle, it melts, creating magma that rises to the surface. Volcanoes can also form at hotspots, which are areas of volcanic activity not associated with plate boundaries. These hotspots are thought to be caused by plumes of hot mantle material rising from deep within the Earth. Section 6. Shaping Landscapes: The Artistic Power of Earthquakes and Volcanoes. Earthquakes and volcanoes are not just destructive forces, they are also the architects of our planet's ever-changing landscapes. Over millions of years, their relentless activity has sculpted mountains, carved out valleys, and even created new land. Volcanic eruptions can create new landforms in a matter of days or weeks. As lava flows and cools, it solidifies into new rock, building up the volcano's cone and creating new land. Volcanic islands, like those in the Hawaiian archipelago, are born from a series of underwater eruptions that gradually build up over time until they breach the surface. Earthquakes, too, can dramatically alter landscapes. Fault lines where earthquakes occur are often marked by dramatic scarps or cliffs where the ground has been offset vertically. Earthquakes can also trigger landslides, which can reshape mountainsides and dam rivers, creating lakes. Section 7. Life Finds a Way, Ecosystems Reforged. While the immediate aftermath of an earthquake or volcanic eruption can be devastating to local ecosystems, life has a remarkable ability to adapt and thrive even in the most challenging of environments. Over time, these disturbed landscapes become fertile ground for new life to take hold. Volcanic soils, enriched with minerals from the Earth's interior, are incredibly fertile. Plants that thrive in nutrient-rich soils quickly colonize the slopes of dormant volcanoes, providing food and shelter for animals. Over time, diverse ecosystems develop, teeming with life that has adapted to the unique conditions of these volcanic landscapes. Even in areas affected by earthquakes, life finds a way. Plants with deep roots or the ability to regenerate quickly are often the first to return after a disturbance. Animals that are adaptable and can survive on a variety of food sources are also more likely to thrive in these changing environments.
Section 8. A history written in stone. Evidence of Earth's fiery past. The Earth bears the scars of its fiery past in its very rocks. By studying these geological records, scientists can piece together a history of past earthquakes and volcanic eruptions, revealing clues about the forces that have shaped our planet over millions of years. Fossils of marine organisms found high in the mountains provide evidence of past tectonic uplift caused by the collision of continents. Layers of volcanic ash preserved in sedimentary rock tell the story of ancient eruptions that blanketed the landscape in ash and debris. Each layer of rock is like a page in Earth's history book, recording the events that transpired over vast stretches of time. By deciphering these geological clues, scientists can better understand the Earth's dynamic nature and the forces that continue to shape our planet today.
Section 9. A Planet in Constant Motion. The Never-Ending Story of Earth's Evolution. Earthquakes and volcanoes are not isolated events. They are part of the ongoing story of our planet's evolution. The Earth is a dynamic system, constantly changing and reshaping itself through the forces of plate tectonics. From the highest mountains to the deepest ocean trenches, the Earth's surface is a testament to the power of these geological processes. While we may not always witness their dramatic effects firsthand, we are constantly surrounded by the evidence of their work. The next time you feel the ground tremble beneath your feet, or witness the awe-inspiring spectacle of a volcanic eruption, remember that you are witnessing the forces that have shaped our planet for billions of years and will continue to do so for billions more. The Earth is a planet in constant motion, a living, breathing testament to the power of nature.